Hi, everyone. Good evening. Thanks for coming over. Appreciate it. I know it's very hard with all the beer noises and food noises. I know that most of you are probably sitting here just to have a place to eat, but we'll take it as well. My name is Elad Ziklik. I'm the group program manager for a product called Cognitive Search, we just announced today in Scott Guthrie's keynote this morning, if you remember. What I want to talk about over the next 20 minutes is walking you through the story of President Kennedy and his assassination, and how we use Cognitive Search to explore this data. So on November 22nd, 1963, President Kennedy was assassinated as he was riding down the streets of Dallas with his motorcade. He was shot by a lone gunman named Lee Harvey Oswald, or at least that's the story that the government wants everybody to believe. And there's been a ton of controversy over the last 40, 50 years to a point where an act of Congress was defined to release all the documents that the CIA had on the investigation of assassination by 2018. And that actually happened. So a couple of months ago, the government released what amounts to about 50,000 pages and documents, which are all the materials that relate to the assassination of President Kennedy. Now, I want to know what's in them, but there's no way that I can actually go and read through these 50,000 documents. So what I want to do is create some kind of a continuous process that ingests this data, enriches it using AI, and searches this and explores this using Azure Search. And as of today, you have a way to do this. Okay, so this morning, Scott Guthrie announced the release of a new product or a new set of features within Azure Search called Cognitive Search that allows you to take your data, ingest it, enrich it with cognitive skills, and then use Azure Search to explore it. Okay? So let's do that. Let's go and explore the JFK files. Fine, good enough. Okay, so here are the JFK files. Okay, so already here on the left-hand side, you can see a bunch of tags that are automatically extracted by running a cognitive skill for entity extraction on this data. You can see a bunch of companies, places, people that have been extracted. You can see that these documents talk about JFK and the CIA and the Act of Congress and whatnot. But I want to start at the beginning. I want to start with Oswald. So you see a bunch of documents, and you see that we have already been automatically assigned to the place in these documents that talk about Oswald. Whether this document is some printed text that we used OCR to understand, whether it's some cursive handwriting that we use to understand, and extracted Oswald, or even a photo. Notice that this photo that appeared in these files does not say anything about Oswald. There's no Oswald written, but we used the computer vision skill to do celebrity recognition, and it provided us with this captioning that this photo is actually Lee Harvey Oswald posing for the camera, which is close enough to be accurate that it doesn't matter. So when I search for Oswald, I get this image back, which is nice. Now, if I go and scroll a bit more down the road and find other documents, I find something here that looks like a typo. I see here something that says GP flow. Okay, and again, my query was for Oswald, but this is actually not a typo. If I go to this website, then some person, whoever that person is, has bothered curating a list of all the CIA cryptonyms on the planet as they relate to the CIA investigation. So GPFLOW is actually the code name for Lee Harvey Oswald according to the CIA. This is the internal cryptonym, the internal code name that they used. So what I went and created was a custom skill that basically passed through this website, extracted all these pairs of cryptonyms, and used this as annotations in the context of my data. So when I search for Oswald, what I get back is also every mention for GPFLOW because this is the CIA cryptonym for Lee Harvey Oswald, which is very nice. Now, as I look at these keywords, at these entities that were extracted, one of them pops out as somewhat irrelevant to the Oswald story. Okay, if you see here, you see Cuba. Now, Oswald actually had connection to Cuba. He was meeting with a person called Sylvia Duran, who was working in the Mexican consulate in Cuba or whatnot. But as you may know or not know, in the 60s, there were a lot of things between the US government and Fidel Castro, who ruled Cuba at the time. There were a lot of operations that the CIA tried to do around Fidel Castro. So let's see if we can actually try and learn a bit more about this. So I'm going to search for Castro and operation. And I find a bunch of documents that relate to something called Operation Mongoose. Now again, I can read these documents and figure out what it's on, But let's see if our AI can actually understand what's in these documents without me even trying. So I'm going to open this knowledge graph that's automatically created based on these documents. And look what pops up here. So what you see here that is these documents, when I ask about the Castro operation, okay, they talk about the mafia, which is actually the Chicago Mafia, Fidel Castro, Operation Mongoose, which is actually an attempt by the CIA to pay the Chicago Mafia to poison Fidel Castro by pills. Now, I don't know what sounds more ridiculous, the fact that this is actually true, this is actually mentioned in the JFK files released by the CIA, or the fact that our AI skills pick this up without knowing anything about the topic. This is completely unsupervised. This graph was not created by somebody manhandling or adding values to these entities. This is just a graph that was created by running cognitive skills through cognitive search on this corpus of documents, and already I can sort of pick up a bunch of interesting pieces as to what went on there, even though it's completely crazy. Now, there's one more thing that I want to do. Whenever the government releases a trove of documents that talk about the assassination of an active president, there is one thing you want to make sure, and that's your name is not on it. Now, my name is not on this, believe me, I checked, but one of Microsoft product names is. And I know what you're all thinking. If there was ever a Microsoft product that was involved in killing JFK, it had to be Windows Vista. But no, this would be SQL Server. Sorry, going back here. So this is a deck. Sorry. This is a deck that was created by the CIA in 1997, talking about how did they build a system to annotate all these documents. There's a bunch of documents here. There's even, if I'll find it, where is it? One slide, sorry. Ah, here it is. It's the architecture that the CIA built in 1997 to do exactly what I showed you. Okay? So they use SQL Server, a bunch of secure telephone units, shared printers and whatnot. This PowerPoint deck is actually pretty interesting. It talks about how many millions of dollars were paid to build this, how many hours of overtime were paid to human employees to go and manually annotate the data and put all those tags around Fidel Castro and whatnot. And we've built this in about 2 days with one developer. Okay? And here is how we build it. So I have to say, I'm keeping the top secret clip out from the CIA. So we've put all of our documents inside Azure storage, inside a blob storage in this case. And then we ran extraction of the content from all these PDFs and PowerPoints and Word documents and whatnot, and ran a set of cognitive skills. Okay, some of the cognitive skills come built in within Azure Search using our Microsoft Cognitive Services for detecting handwriting and OCR, computer vision, entities, and some were custom. Okay, I used Azure Functions using Azure Machine Learning to do a bunch of interesting things. So cryptonym is one example. Let me show you the other example. So if I close this, and I go search for Oswald, what I really want to find is the top secret things, the things that even when the government actually released, they still kept redacted. So if I go all the way down here, you'll see a redaction flag. I'm going to check it in. And what you'll see here is all the documents that the government still redacted. Now, obviously, we don't have any cognitive skills or computer vision skills to know what a redacted document is. So I partnered with one of our data scientists to help me build a redaction classifier. Used Azure Machine Learning, created a very simple redaction classifier. I called it. I will show you in a minute how I did that. And I use this now as a facet in my search index. And then I can find all the documents that were redacted or very poorly redacted with a not dark enough marker, so you can actually still read that it says NSO John Moretti and Major blah, blah, blah thingy, but like, it's the government, what can you expect? So this is pretty awesome. Let me show you how we actually do this. So all this data, all this built-in cognitive skills or custom skills that I created myself are being put inside a search index to allow me to explore the data. And let me go and show you how easy it is to get started directly from the Azure portal. So this is the Azure portal. I'm going to go directly to my search service that I already provisioned. So this is my search service. So if you have an Azure search service, you can now go and start using cognitive search. And the easiest way to do it is just to import your data. So I'm going to connect to my data. Azure Search can automatically ingest data from a bunch of Azure resources, SQL DB, blob storage, table storage, Cosmos DB. You can also have a push API to upload data from whatever proprietary mechanism that you want. But in the essence of time, I'm going to just connect to my existing blob. So I have an existing blob here that contains the JFK files data. It's going to look into the schema of these documents. It's going to take a couple of seconds, sampling the data sources. And in about 2 or 3 seconds, it's going to understand what's going on. It's going to offer me what kind of annotations the owner run on this data. Oh, come on. Never trust anything that is live. Yeah, OK. So I can go and enable OCR if I want to run all these scanned images and all these PDFs, extract all the images, and generate a document from them. I can run built-in skills, like extracting people names and organization names and locations, all the things you've seen on the left side when we showed you the DFK files. Detect languages, which are pretty useful. Some of the documents here are in Russian. So you want to move this language field to the rest of the skills so they can actually know which kind of entities in what language to go and search. And I'm done. If I click OK, Azure Search, which is an enterprise-grade system, this is not a one-time provisioning thing. I just deploy a pipeline that can now listen in or crawl to all of these data sources, and whenever something changes, plug those documents, run them through the indexer, and give me the results in a search index that I can go and explore. And it's actually pretty easy. This is what actually gets created in the end. Okay, this is the JFK file skill set. If I clicked on OK there, what would actually happen is this JSON blob. It says, it's hard to see, but it says OCR and handwriting and vision and custom JFK cryptonyms and blah, 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 blah. Let me show you how easy it is to create a custom skill. Okay. So this is my custom skill for detecting redacted images. Okay. So all I had to do is tell it what's the batch size, which is 1. Tell it that it's a custom web API skill. What is the source? The source is what you call normalized images. On any PDF, take every image, every page, and send it to the skill. And what should be the output? The output in this case is a redaction score. Okay? And you want to append it to every image. So this is how I, within my skill set, manually annotated the JSON object, because right now you cannot create custom skill in the profile in the portal. You actually need to go to the SDK to add this custom reduction work. And the actual Azure function that I call is also about 20-something lines of code. Okay? It parses the request, it creates a redaction classifier, and it basically calls it. Delivers the image, waits for a reduction score, and then returns it as part of the flow. So yes, I needed some smart data scientists to go and build this thing, use some Python package, something, which I actually know nothing about. Once I got this thing, I used Azure Machine Learning to create a container, a web hook, and I use this thing to plug it into my skill set so I can actually run this as part of the cognitive search flow. And while I've done this on JFK, we have customers in private preview, and today public preview, that are doing it on legal contracts, engineering plans, forms, PDFs, Visios, Office documents, SharePoint documents, anything that you can think of. And tomorrow we actually have a session. So tomorrow we actually have a session that you can go and learn more about how to actually do this, meet some of our customers that will show you hands-on what skills that they have done, what examples they've used, how the data looks like, what the experiences look like, having a built-in AI powered with Azure Search. If you want to see specifically about JFK, we have published everything on GitHub, all the examples, all the skills, all the pipeline, all the files even. You can go to GitHub, find the JFK files, and deploy one of these on your own, either on JFK or on your own data. Or go to the Azure portal, and as of this morning, this is out there and available, and you can provision your own cognitive search instances. Thank you very much for staying with me this late.